Hello student, how are you? Welcome to the chemistry lecture. Can you hear me? Please tell me. Can you hear me? Yes or no? Rajat Singh is saying yeah, ekdam badhiya, fine sir. Chaitanya Chauhan is saying yes sir. Okay. Okay. So what we were talking about in the last lecture? In the last lecture, we were talking about volumetric analysis, and we have seen different terms, different types of volumetric analysis. And in the last lecture, we were talking about the titration curve or neutralization curve. Yes or no? यही देख रहे थे कि नहीं हम लोग? याद है कि नहीं आप लोगों को? In the last lecture, we have seen neutralization curve or titration curve. Okay, Pramodini is saying yes. Okay, so we have seen the word definition of neutralization curve. What is neutralization curve? Neutralization curve, it is the graph or plot of neutralization curve is nothing but, or it is the graph or plot of H plus ion concentration or pH versus the titrant. pH versus titrant. Titrant means a burette solution. A solution which is taken in a burette. It is called as a titrant. Okay? So then we have seen different terms. We have seen neutralization point, we have seen equivalence point, we have seen end point, then we have seen a suitable indicator. What are the criteria for suitable indicator? Then out of that suitable indicator you have to choose the best indicator. And how will you choose the best indicator? While choosing the best indicator, you have to see the pH change or pH range during that neutralization curve or titration curve, and the pH at equivalence point, that we have to see. So according to these two things, we can choose a suitable best indicator for that titration. Okay? So today we will see the titration of strong acid and strong base. Today we will see titration of strong acid and strong base. That is, the strong acid is HCl, hydrochloric acid, and strong base, that is NaOH, sodium hydroxide. So we will see which is very popular titration. So that we will see. Okay. Okay. So let's start today's lecture. Let's start today's lecture. So today's lecture number 5 of volumetric analysis. Okay. Okay. So we'll see. So this we will see the titration of strong acid and strong base. Strong acid we will take HCl, that is hydrochloric acid, and strong base we will take NaOH, that is sodium hydroxide, which is the best example of strong acid and strong base titration. So in this example we will take the concentration of 0.1 molar HCl or 0.1 normal HCl. Both are same in case of HCl and NaOH, and 0.1 molar NaOH. In case of NaOH and HCl, normality and molarity are same because of they are dibasic acid and diacidic base. Okay, so we will see. So in this HCl we will use it as a titrant. That means this HCl we will take in conical flask. HCl we will take in conical flask, and NaOH we will take this solution in burette. We will take this solution in burette. Okay. So after the titration we will get the neutralization curve or a titration curve. See this titration curve. Okay. Now here we will see this is a y-axis. This is y-axis and this is x-axis. So on the y-axis, that is pH is given, and on the x-axis, that is ml volume is given, ml of NaOH added, that is titrant. This NaOH is acting as a titrant here. NaOH is acting as a titrant here. Okay, so please see this graph carefully. So at the starting or 0 time the pH of the solution is 1. At the 0 time pH of the solution is 1. Please remember this. Then as you go on adding the NaOH, there is steady and increase in pH up to the 3, up to the pH unit 3. Then after the pH unit 3 or after the volume 24.5, there is a sharp and sudden increase in the pH of takes place. Okay, so this is the titration curve or neutralization curve. This is called as a titration curve or neutralization curve of the strong acid and strong base titration. For example, NaOH and HCl titration. So this titration curve has some important point, some important feature. That features are called as a characteristics of the titration of strong acid and strong base. So we'll see the different characteristics or different point which are important of this titration curve. So next point is the characteristics of the above curve. Above curve means the strong acid and strong base curve. So this is the first point, first characteristic point. The pH at the start it is 1. The pH at the starting it is 1 and ends at pH 10. So at the start or time 0, what will happen? Only zero point 0.1 normal HCl is present in 0.1 normal HCl is present in conical flask. That is, we have taken 25 ml of HCl. How many volume? This is the concentration of HCl, normal or molar, on 25 ml. So at the 0 point or at the starting, the solution has only the HCl. So that's why its pH is 1. So how that pH is 1, that we can calculate, that we can determine by using the pH meter, or we can determine or we can calculate the theoretical pH also. That we will see in the coming lecture. Okay, so how the pH of the starting is 1. कैसे pH 1 कैसे, that we will calculate, don't worry about that. Or experimentally also we can determine by using a pH meter. pH meter, one instrument is there that is used for the determination of the pH. Okay, so this is the first characteristic point. The pH at the start it is 1 and ends at 10. So this is first point. Now if you have pen, copy, notebook, you please write down these characteristic points. Okay, yes or no? Okay, so this is point number 2. There is a steady and linear increase in pH with the addition of NaOH up to the volume 24.5. So there is steady and linear increase in pH. So as we add NaOH, जैसे जैसे आप लोग NaOH ऐड करते जाओगे ड्रॉप बाय ड्रॉप, जैसे जैसे आप लोगों को क्या हो जाएगा, steady and linear increase in the pH will take place. So up to the 24.5 ml, your pH will increase up to the value, unit of 3. So at the 24.5 ml, your pH will be the 3. Okay, so this is your third point. There is steady and linear increase in the pH takes place as we go on adding the NaOH solutions to the conical flask. Okay, then the point number 3. Point number 3, sharp and linear increase in the pH in the volume range 24.9 to 51. So we have seen there is a sharp increase in the pH will take place. This S-shaped curve will take place. So this sharp and large increase in pH will take place. Okay. So this is the point number 3. Sharp and large linear increase in the pH in the volume range 24.9 to 25 ml of the NaOH. So this is a point number 3. Then point number 4. The pH change near the equivalence point covers approximately 3 to 10 pH units. So near the equivalence point or near this curve, the pH range is 3 to 10 pH unit. pH range is 3 to 10. So during this, here your pH will be 3 and here it will be 10. So this is the equivalence point. From this to this, it is called as a equivalence point, and the pH change the near point covers approximately 3 to 10 pH units. So this is the point number 4. Then point number 5, the pH at equivalence point is 7, which is very important. pH at equivalence point is 7. So pH change near the equivalence point covers value 3 to 10 pH unit, and the pH at equivalence point which is 7. pH at equivalence point is 7. This is important point. Whatever the equivalence point you will get, equivalence point we will get at the approximate 25 ml volume. If you add 25 ml of NaOH, at that point you will get the equivalence point, and the pH at the equivalence point is 7. pH at equivalence point is 7. Okay, so this is the fifth point. The next point, the pH with further addition of NaOH is not linear and remains constant in the volume range 25.1 to 26 ml. So after the equivalence point is over, then there will be the no increase in the pH takes place. So this point, see here, this point, so it will remain constant. आपने कितना भी NaOH ऐड किया ना तो इंक्रीज नहीं हो जाएगा. At this point it will get constant. ठीक है. So after the addition of NaOH after the equivalence point, that means 25 ml NaOH, after the 25 ml NaOH आपने जितना भी NaOH ऐड किया है, there is no further increase in the pH of the solution takes place. So these are the some characteristic point or characteristics of the curve of strong acid and weak base. ठीक है. If you understood, then we will go to the next point. समझ में आया आपको लोगों को characteristic point? Tell me. Then we will go to the choice of indicator. किसको किसको समझ में आया? Nobody answer. Nobody understood this characteristics point of the. Yes, Pramodini. Raj is saying, sir, my answer. Okay, Raj. That we will discuss at the end. Raj, I don't understand your question first of all. You write your question, you formulate your question in a proper sentence, and then you can ask me. We will discuss that at the end. Okay? So now everybody is saying the yes sir. So we will go to the next point, that is choice of indicator. Next point is choice of indicator. So there are different indicators. There are 4 suitable indicators are there, which we can use for the this titration of strong acid and weak base. But out of that 4, we have to choose the best indicator. So how will you choose? That we will learn in this topic. So next topic is choice of indicator. The vertical part of the curve has a pH in the range. Vertical part means this part. Vertical part means this part, which has pH in the range. Here pH is 3 and here pH is 10. So in the range of 3 to 10 units. This vertical part or vertical part of the curve has pH in the range of 3 to 4 units. This is the first point. Then the pH change at the equivalence point is 7. But the pH at equivalence point is 7. Now there are 4 suitable indicators for this titration is there. We have total 4 suitable indicator. Which 4 suitable indicator we have? These 4 suitable indicator we have. Methyl orange we have, methyl red we have, bromothiamol blue है आपके पास, phenolphthalein भी है, and उसके pH range भी दिए. Methyl orange has pH range 3 to 1, 3.1 to 4.4. Methyl red has a 4.2 to 6.3. Bromothiamol blue has a 6.0 to 7.6, and phenolphthalein has 8.3 to 10. So here this point you have to take while choosing the best indicator. Please आप लोगों को ये देखना है कि pH equivalence point में कितना है. So here pH at the equivalence point is the equivalence point is 7. So this you have to keep in mind. So out of that, which has a pH range near the 7? So bromothiamol blue has a pH range 6 to 7.6. So the best indicator for the above reaction is bromothiamol blue. Best indicator, yes. Istesham is saying bromothiamol blue as a range 6 to 7.6. So bromothiamol blue is the best indicator for this titration. Bromothiamol blue is the best indicator because it covers the 3 to 4 unit. If you see 6 to 7.6 and the pH at equivalence point is 7. So which indicator will show color change at the equivalence point or pH 7? Bromothiamol blue will show the color change. So the best indicator for this titration, that is 0.1 molar HCl versus 0.1 molar NaOH, that is strong acid strong base titration. For this titration, this is the best indicator. For this titration, this is the best indicator, bromothiamol blue, because the pH at equivalence point is 7 and bromothiamol blue can show color change in the range of 6 to 7.6 pH. That's why this bromothermal blue, which is the best indicator for this titration. ठीक है, understood how to choose or how to identify the best indicator? You have to see the pH range and the pH at equivalence point. These two point you have to remember, the pH range and pH at equivalence point. ठीक है. Okay, then the next point we will see the calculation of pH at various stages. मैंने आप लोगों को पहले ही बोला था कि we can calculate at the start or time 0 the pH is 1. How that 1 comes, that we will calculate. So pH at the start of the titration, pH at the start of the titration, or it is called as a pH at 0 time. It is also called as a pH at 0 time. That means 0 time means before the reaction, before the addition of NaOH. That is called as a pH at 0 time. It is called as a pH at 0 time, or it is also called as a pH at the start of the titration. Now at the start of the titration, what will happen? At the start of the titration, this is the condition. At the start of the titration or at 0 time, only 25 ml 0.1 molar HCl is present. Only 25 ml 0.1 molar HCl is present and 0 molar NaOH present in the conical flask. 0 molar NaOH is present in the conical flask. So this is the condition. Now at the starting point or time 0, the H plus ion concentration will be 0.1 molar or 10 raised to minus 1 molar. So this is the concentration of H plus ion. Because HCl is a strong electrolyte, it will dissociate completely into H plus and Cl minus aqueous. H plus and Cl minus aqueous. Initially concentration is 0.1, will give you 0.1 of H plus and 0.1 of Cl minus ion. So due to this, at the starting or at the 0 time, the concentration of H plus ion is 0.1 molar or 10 raised to minus 1 molar. Now once you know the concentration of once you know the concentration of H plus ion, you can calculate the pH. अगर आपको H plus ion के concentration पता है, then you can calculate the pH. Yes or no? Can you calculate pH or no? कर सकते हो अगर आपको H plus ion का concentration पता है. If you know the concentration of H plus ion, then can you calculate the pH of the solution? Istisham is saying yes sir. How you can calculate the pH? If you know the H plus ion concentration, then how can you calculate the pH? Tell me Istisham. How will you calculate? The concentration of H plus ion is given, that is 0.1 molar. Concentration of H plus ion is given, that is 0.1 molar. This is given to you. So how will you calculate the pH? Tell me. Just take 1 upon log of H plus ion. Istisham, that is not the answer. You know what is pH? pH is nothing but negative log of concentration of H plus ion. Negative log of concentration of H plus ion. Now if you know this thing, you can take negative log. You can take negative log. So this is, ये जो इस्तेशाम ने बोला था ना, वो ये है. But this is your book's language. pH is nothing but the negative log of H plus ion concentration. Now you know H plus, put the value of H plus ion. Put the value of H plus ion. pH is equals to log of 1 minus 10 raised to minus 1. How much is, कितना आ रहा है? Take negative log of 0.1 molar. Take negative log of 0.1. Then you will get the pH. Then you will get the pH. अगर आपने साइंटिफिक कैल्सी लेके नहीं बैठे हो तो टेक द साइंटिफिक कैल्सी एंड कैलकुलेट. हाउ मच इज द नेगेटिव लॉग ऑफ 0.1? यस, इट इज 1. It is 1. So pH at the start of the titration, pH at the start of the titration is 1, जो कि हमारा फर्स्ट पॉइंट था. मैंने उस टाइम भी बोला था कि how this pH at the starting is 1 कैसे आता है, then we will calculate it. So we have calculated pH at the 0 time, it is 1. pH at 0 time, it is 1. ठीक है, understood how to calculate the pH at the start of the titration? Tell me yes or no. समझ में आया कि नहीं आया? How will you calculate? Simple formula is there. pH is nothing but the negative log of H plus ion concentration. Akansha is saying yes. Okay, only Akansha understood. प्रमोदिनी को भी समझ में आया है? Okay, चलो, very good. Now we will go to the next point. Now the pH after 2 ml addition. pH after 2 ml addition of 0.1 molar NaOH. Now we will calculate the pH of the solutions after the addition of 2 ml 0.1 molar NaOH, and we can calculate the H plus ion concentration. First we have to calculate the H plus ion concentration, and once you know the H plus ion concentration, you can calculate the pH, because you know the pH is equal to negative log of H plus ion concentration. So first of all you have to calculate the concentration of H plus ions in the given solution. So before the equivalence point, what will happen? Before the equivalence point, solution contains excess of H plus ions. Before the equivalence point क्या होगा? Solution में H plus ions ही present होंगे, excess में present होंगे. So you have to calculate the concentration of H plus ions. Okay, so how will you calculate? One formula is there. So this formula is there. Concentration of H plus ion is equal to millimoles of H plus divided by total volume in ml. So this is the formula. By using this formula, you can calculate the concentration of H plus ion. And once you know the concentration of H plus ion, you can calculate the pH, because pH is equal to negative log of H plus ion concentration. So first we have to calculate the millimoles of H plus, or concentration of H plus ion, which is equal to millimoles of H plus divided by total volume in ml. Now how will you calculate millimoles of H plus? Because now after addition 2 ml, there are H plus ions is present, and there O minus ions are also present. So some H plus ions are neutralized by OH minus ion. So how will you calculate the millimoles of H plus ion? So millimoles of H plus ion you can calculate the millimoles of acid taken. This is the formula. Millimoles of H plus ion. Millimoles of acid taken minus millimoles of base added. So this is H plus is equal to, or concentration of H plus is equal to millimoles of acid taken minus millimoles of base added divided by total volume in ml. So now here millimoles of acid taken. So how will you calculate millimoles of acid taken? Concentration into volume. Concentration into volume. So you can calculate the millimoles of acid. Now what is the concentration of acid? Concentration of acid is 0.1, and volume कितना लिया था हम लोगों ने acid का? 25 ml. So this is the millimoles of acid taken, that is 0.1 into 25. Now what is the millimoles of base added? Millimoles of base added is nothing but the concentration into volume. Concentration कितना है NaOH का? Concentration is 0.1. Concentration is 0.1 and volume is how much? Volume is 2 ml. So divided by 2. So put the value, and what is the total volume? 25 plus 2. Total volume is 27. So this is, now this is the millimoles of acid taken, and this is the millimoles of base added. So this is the concentration, that is 0.1 into 25 minus millimoles of base added, that is 0.1 into 2. Total volume will become 27. Now you can solve this, and you will tell me the pH. You solve me and you will tell me the pH after the addition of 2 ml 0.1 molar NaOH. Solve the equation and tell me the pH. ठीक है, चलो जल्दी से ले लो, कॉपी ले लो, नोटबुक ले लो, पेन ले लो, साइंटिफिक कैलसी ले लो. Put the values correctly and tell me the answer. That is the pH. बोलो जल्दी से. So here 0.1 into 25, it will become 2.5, and 0.1 into 2, so it will become 0.2. So 2.3 minus 27. 2.3 minus 2.3 sorry 2.3 divided by 27 कितना आ रहा है ये 2.3 divided by 27 how much is this that will be your correct very good इसके सामने से बोला है 8.5 into 10 raised to minus 2 so this is your concentration of H plus ion this is your concentration of H plus ion कितना आ रहा है वो how much is this इसके सामने बोला 8.5 into 10 raised to minus 2 and take the negative log of this answer take correct Chaitanya 0.0852 and take the negative log of this you will get the pH take the negative log so pH is equal to negative log of H plus ion concentration so negative log of 5 into 10 raised to minus 2 कितना आ रहा है tell me how much is this negative log of 0.085 correct pH is 1.07 so you will get the value of pH this is the value of pH 1.07 so in this way you can calculate the pH at any instant you can calculate the pH at any instant at any time at any volume of NaOH added ठीक है yes or no can you calculate the pH कर सकते हो या नहीं कर सकते हो टेल में you have the formula of H plus ion that is millimoles of H plus taken divided by total volume so how will you calculate millimoles of H plus that is millimoles of acid taken divided by millimoles of base added and what is the formula for millimoles is concentration into volume same you have to apply for the base and put the value in this equation you will get the H plus ion after the once you know the H plus ion you can calculate the pH yes or no इस्तेशाम कर सकते हो या नहीं कर सकते टेल मी बोलो जल्दी से हम लोगों को नेक्स्ट यस चैतन्य and Istisham is saying yes sir only 2 students understood this and what about others चले गए वो लोग सिर्फ इस्तिशाम एंड चैतन्य ही लेक्चर में है ऐसा लग रहा है मुझे यस और नो व्हाट अबाउट अदर्स विनायक मी टू वेरी गुड विनायक आकांक्षा पण आहे आकांक्षा इज सेइंग यस सर वेरी गुड okay now one Pramodini no sir understood Pramodini is also there Ganesh is also there Shalu is also there okay very good then we will go to the next point the pH after 5 ml addition of 0.1 molar NaOH next point is now you people have to calculate the pH after the addition of 5 ml and 0.1 molar NaOH now you people calculate this and tell me the pH after 5 ml addition of 0.1 molar NaOH आप लोगों को कैलकुलेट करना है और मुझे बोलना है ठीक है ओके चलो जल्दी से बोलो व्हाट इज द वैल्यू इस्तेशा में सेइंग सर 5 मिनट्स ओके 5 मिनट्स तो नहीं लगने वाले फिर भी टेक चलो ले लो इट विल टेक हार्डली 2.5 minutes it will take hardly 2.5 minutes don't worry you can calculate and tell me no problem at all take a 5 minute The pH after 5 ml addition of 0.1 molar NaOH, that you have to calculate. Take a 2 minutes and calculate. Take a 2 minute and calculate. हो गया? जल्दी से कैलकुलेट करो. 0.4 Pramodini, is it pH or what? Pramodini, is it pH or what? Istisham pH is saying pH 1.173. Correct. Very good. Very good. Correct. Good answer. pH is 1.173. pH is 1.173 after the addition of 5 ml 0.1 molar NaOH. This will be your pH. This will be the pH of your solution. ठीक है, after addition of 5 ml NaOH. ठीक है. ठीक. Now see on your screen. I have solved this for you people. See, it is your screen. See, how will you calculate? This is the formula H plus. Ajinkya Sarve is saying pH is 1.176. Correct. So this is the formula. H plus is equal to millimoles of H plus divided by total volume in ml. So how will you calculate millimoles of H plus? This is millimoles of acid taken minus millimoles of base added. So millimoles of acid taken, how will you calculate millimoles? It is concentration into volume. It is concentration into volume. Here also. Here concentration of base into volume of base added. So volume of base added is 5, concentration of base is 0.1 molar. Yes, acid taken is 25 ml acid taken, concentration is 0.1 molar and total volume will become 25 plus 5, it will become 30. So कितना आ रहा है ये? 2.5 minus 0.5 divided by 30. So 2 divided by 30, you will get the concentration of H plus ion. Take the negative log, you will get the pH and pH will comes 1.176. pH will come 1.176. So this is the pH after addition of 5 ml NaOH. After addition of 5 ml NaOH. ठीक है? Okay, good. Then the next, pH at equivalence point. The pH at equivalence point. So the pH at equivalence point. At equivalence point, what will happen? At equivalence point, what will happen? At the equivalence point, millimoles of acid equals to millimoles of base. So this point is called as a, this point we will call as a equivalence point. So here millimoles of acid at the equivalence point is 2.5 and millimoles of base at equivalence point is 2.5. That means at the equivalence point all the millimoles of acid will get neutralized by all the millimoles of base. All the millimoles of acid will get neutralized by the millimoles of base, and at this point this solution will be a neutral solution. When the millimoles of acid exactly equals to the millimoles of base, then that solution is called as a neutral solution. That solution is called as a neutral solution. Okay? That solution is called as a neutral solution. And neutral solution, if the solution is neutral, then the pH will be 7. If the solution is neutral, then pH of that solution will be the neutral. So this is the theory behind that. This is the theory behind that. How will you calculate? There are some formulas. That formula we will see first. ठीक है? That formula we will see first. ठीक है? you people write down this or take a screenshot. You people write down or take a screenshot of this. So can I remove this? Can I remove this? Take a screenshot. 1, 2, 3. Okay, good. So at the equivalence point, what will happen? All the H plus ions are neutralized by OH minus ion. All the H plus ions are neutralized by OH minus ion. So the solution will be neutral. The pH at equivalence point is given by the formula. pH at the equivalence point is given by the formula. This is the formula. pH is equal to 1 half pKw. pH is equal to 1 half pKw. What is the pKw? So Kw of water is given. Kw of water is 1 into 10 raised to minus 14 at 25 degree. So you know Kw, you can calculate pKw. pKw will come 14. pKw will come 14. So pH is equal to 1 half of pKw. So pH will be 7. So pH will be 7. So pH will be the 7. So this is the formula by which you can calculate. Or you can simply apply your theoretical knowledge. You can calculate millimoles of acid. When exactly becomes to the millimoles of base added, then that point is called as equivalence point, and that at that point solution will become neutral. If that solution is neutral, then that pH of that solution will be 7. Okay, so this is the pH at equivalence point. Okay, understood this? समझ में आया ये आप लोगों को? Then we will go to the next. pH after 26 ml addition. pH after 26 ml addition. So after the equivalence point कहाँ पे आ जाता है? Equivalence point आपको मिल जाएगा at 25 ml of 0.1 molar NaOH. If you add 25 ml 0.1 molar NaOH, at that point you will get the equivalence point. And after the addition of 26 ml NaOH means after the equivalence point. So after the equivalence point, what will happen? After the equivalence point of what will happen? There will be the excess of OH minus ion. There will be excess OH minus ions present in the solution. Because of what? Because of H plus ions are got neutralized by OH minus ions, and your solution will contain only OH minus ions after the equivalence point. 26 ml means it is after equivalence point. Equivalence point you will get at 25 ml. Okay, understood this? So after the equivalence point, what will happen? After the equivalence point, solution contain excess of OH minus ion. After the equivalence point, solution contains excess of OH minus ion. And so instead of concentration of H plus ion, you have to calculate the concentration of OH minus ion. Ions. And there is formula. How will you calculate the OH minus ions? Similar formula is there. Okay? So this is the formula. OH minus ion is equal to millimoles of OH minus ions means millimoles of OH minus divided by total volume in ml. Now here OH minus, how will you calculate millimoles of OH? Millimoles of base added minus millimoles of acid taken. This is the formula. Millimoles of base added minus millimoles of acid taken divided by total volume in ml. Now here millimoles of base added. Base added means concentration multiplied by volume. What is the concentration of base? 0.1. And what is the volume of base added? 26 ml. So 0.1 multiplied by 26. And here millimoles of acid taken, it is 0.1 concentrated and 25 ml आपने HCl लिया था. So it will come 0.1 into 26 minus 0.1 into 25. तो ये कितना आ जाएगा? 2.6 minus 2.5 divided by 31. So calculate this. You will get the value of concentration of OH minus ion. आपको क्या मिल जाएगी? तो concentration of OH minus ions. ये आप लोगों को पता चलेगा. Tell me the value. Concentration of OH minus ion. कितना आ रहा है वो? Tell me. Don't tell me the pH directly. Don't tell me the pH directly. Don't tell me the pH. Tell me the pOH. First of all, tell me pOH. pOH की वैल्यू कितनी आ जाएगी? बोलो जल्दी से. मैं कैलकुलेट करता हूँ आप लोगों के लिए. pOH कितना आ जाएगा? बोलो जल्दी से. I have calculated within 2 minutes. I have calculated it. बोलो जल्दी से. वैल्यू ऑफ pOH बोलो मुझे. pOH कितना जाएगा? ये देखो आपके स्क्रीन पे pOH is 2.70. करेक्ट स्टेशन. pOH is 2.70. and once you know the pOH, अगर आपको pOH पता है, so you can calculate the pOH because of you know this famous equation pH plus pOH is equal to 14. Apply this equation. pOH is pOH plus pH is equal to 14. Now you know the pOH, its value is 2.71. You can put the value of 14 minus 2.71. You will get 11.29. You will get the 11.29. So in this way you can calculate the pH also after the equivalence point. After the equivalence point आप लोगों को क्या करना है? After the equivalence point, don't calculate the concentration of H plus ion. Please remember this. After equivalence point, don't calculate the concentration of H plus ions because of what happens? Because of after the equivalence point, your solution will contain excess of OH minus. After the equivalence point, your solution will contain excess of equivalence ion. So it is better to calculate the OH minus ion. So it is better to calculate the concentration of OH minus ions. And the formula is there. So this is the formula. Concentration of OH minus ions is equal to millimoles of OH minus divided by total volume. So this formula will become OH minus is equal to millimoles of base added minus millimoles of acid taken divided by total volume in ml. Once you get the value of pOH, you can use the famous equation pH plus pOH is equal to 14, and from that you can calculate the pH. So फर्स्ट आप लोगों को क्या देखना है? आप लोगों को देखना है कि इक्विवेलेंस पॉइंट अपने कितने ml पे आ जाता है, and after that ml your solution will contain the excess of OH minus ion. After that your solution will contain excess of OH minus ion. So it is better to calculate the concentration of OH minus ion instead of calculating the concentration of H plus ions. ठीक है, समझ में आया? Okay, then calculate the pH after 30 ml of NaOH addition. Calculate the pH after 30 ml of addition of 0.1 molar NaOH. ठीक है, ये calculate करना है आप लोगों को ना. Now what is the value of pH that you have to tell me? चलो जल्दी से calculate करो. pH after 30 ml addition of 0.1 molar NaOH. Calculate and tell me. Calculate and tell me. सिंपल है, कुछ भी नहीं है. मैंने आप लोगों को एक कैलकुलेट करके दिखाया है. कुछ भी उसमें डिफिकल्ट नहीं है. कुछ भी डिफिकल्ट नहीं है उसमें. ठीक है. नाउ टेल मी. How will you calculate? Show the equation. Okay, I will show the equation. I will show you the equation. Don't worry. Okay, these equation are there. Take clear equation. Take the equation and calculate. So instead of this 26, you have to take 30. 30 ml आपको लेने का है. ठीक है. Now calculate and tell me. Correct. Very good. pOH is 2.4. Therefore pH is 11.96. Correct. See, the answer is here. The answer is on your screen. देख क्या है? pH after 30 ml means after the equivalence point. After the equivalence mean that means you have to calculate the concentration of OH minus ions. And what is the formula to calculate the concentration of OH minus ions? Formula is here. OH minus ions is equal to millimoles of OH minus ions divided by total volume. So OH minus ion equals to millimoles of base added divided by millimoles of acid taken divided by total volume in ml. So millimoles of base added, concentration into volume. Concentration is 0.1, volume is 30 ml. Concentration is 0.1, volume is 30 ml. And ये तो सेम रह जाएगा 0.1 and 25. So कितना आ जाएगा ये बोलो मुझे? 55. Answer आ जाएगा pH is 3.041. So this equation you know, put the value, you will get the pH is equal to 11.96. You will get the pH is equal to 11.96. This will be the answer. ठीक है? Got it or not? समझ में आया कि नहीं समझ में आया? Now, then we will go to the next. We will summarize this. We will summarize all this value in the form of table. So this table contains ml of NaOH added and pH at that respective value of NaOH added. For example, at 2.25 ml NaOH added, your pH will be 1.08. Your pH will be 1.08. अगर आपने 5 ml NaOH ऐड किया, अगर आपने 5 ml NaOH ऐड किया, तो pH आ जाएगा आपको 1.18. फॉर 10 के लिए आ जाएगा 1.37, 20 के लिए आ जाएगा 1.95, 24.50 के लिए आ जाएगा 3, and at the equivalence point at 25 ml, this is your equivalence point. At the equivalence point, the solution will become neutral and your pH equivalence point में आपका pH 7 ही आना चाहिए. Please remember this. So at the equivalence point, your pH will be the 7. After the equivalence point, आप लोगों को यहाँ तक आप लोगों को क्या calculate करना था? Before the equivalence point, you have to calculate the concentration of H plus ion. After the equivalence point, you have to calculate the concentration of OH minus ion. After the equivalence point, you have to calculate the concentration of OH minus ion. That means after the addition of 25 ml. So 25.02 के लिए कितना आ जाएगा? See, basic pH is there. 9.60 means it is basic pH. It is basic pH. 25.50 के लिए कितना आ जाएगा? 11 आ जाएगा. and 26 के लिए आ जाएगा 11.29. 26 के लिए कितना आ जाएगा? 11.29. So we have summarized the pH. You can calculate the pH at any instant. You can calculate it experimentally just by measuring the pH by using a pH meter instrument, or you can theoretically you can also calculate. To calculate theoretically, you should know the millimoles, or you should know the concentration of H plus ion, that is before the equivalence point. After the equivalence point, you should know the concentration of OH minus ions. This is the principle behind it. This is the principle behind it. Understood? All of you? Yes or no? Please tell me, then we will stop here. Tell me, then we will stop here. Okay, Ganesh, Vidhi, Vinayak, Chaitanya, Akansha saying yes sir. Okay. Now you can practice it at home. You can practice it. एग्जाम में ऐसे प्रॉब्लम्स आपको बहुत से आने वाले हैं. So आप लोगों को प्रैक्टिस होना चाहिए. How to calculate millimoles, how to calculate H plus, how to calculate OH minus ions, when to calculate H plus ion concentration, or when to calculate H plus ion concentration. Please remember that before the equivalence point, you have to determine the concentration of H plus ions. After the equivalence point, you have to calculate the concentration of OH minus ions. Before the equivalence point, there are excess of H plus ions present in the solutions. After the equivalence point, there are excess of OH minus ions present in your solution. And at the equivalence point, number of H plus ion will be equals to number of OH minus ions. That means in other words, H plus ions are neutralized by OH minus ions and your solution will become neutral, and at the equivalence point you will have the pH equals to 7. Okay? This is the summary of today's lecture. So we have finished the titration curve for strong acid and strong base. That is, we have seen HCl and NaOH example. Today we have finished the titration curve for strong acid and strong base. So I think we will stop here. Next point, different strong and weak acid is there, that we will see in the next lecture. Tomorrow there will be no lecture. Please remember this. Tomorrow there will be no lecture because tomorrow I have supervision work. Supervision work of TYBSc or TYBA. Final year exams are going on. So tomorrow I have supervision work. So there will be no lecture tomorrow. Saturday we will meet at 2:30. Saturday we will meet at 2:30. ठीक है? Understood? Okay. Now, if you have any problem, you can ask me. One problem किसी ने भी मुझे पूछा था, लेकिन I can't understand your question. कौन था वो? I can't understand you. You first formulate your questions and then you ask me. Okay, very good. That means everyone understood today's lecture. Yes or no? Akansha, Amisha, Ajinkya, Ganesh, they are saying yes sir. What about others? Tomorrow there will be no lecture. Please remember this. Pramodini, Nutan. ठीक. Now any problem about today's lecture, you can ask me. If you have any problem, you can ask me. I will activate the link for your attendance, and that link will be open only for 5 minutes. Please remember this. That link will be open only for 5 minutes. Now shall I stop here? Please tell me. Shall I stop here? Yes sir. Okay. Goodbye. Have a good day. झालं बाळा लेक्चर.